In this video, we are going to use method of substitution or method of derivatives to solve integral that involves trig functions, trigonometric functions. Okay, let's start with easy one. Integral square root sine x cosine x dx. Let's say if I am a student and I'm going to solve it, what I would notice right away, I have sine, I have cosine. What is interesting about this fact? The derivative of sine is cosine. That is the key part here, which means what I'm going to do next, I am going to substitute. So if I substitute my sine x with t, for example, then if I take derivative, right, because I need to represent dx also with t, dt. So if I take derivative of dt here, and here of sine x, it's going to be cosine x, and derivative of x, right? Because we don't know what x is. So cosine x dx, right? Okay, so what is interesting? Look here. We have here cosine x dx, and we have here cosine x dx. I can replace with dx dt, right? So from here, we are going to get integral square root sine x cosine x dx equal integral square root t dt. Yes? Entire cosine x dx I replaced with dt. So from here, we have t to power 1/2 dt, and that is equal t to power 1/2 plus 1. Here is also divided by 1/2 plus 1 and plus c. So it's finally it's going to be equal t to power 3/2, because 1/2 plus 1, it's get 1/2, which is 3/2, and divided by 3/2 plus c, and finally it's going to be equal 2/3 2t to power 3/2 plus c. Okay, and finally we can replace our t with sine x. It's going to be 2/3 hold on, why did I put here 2? Okay, it's going to be equal 2/3 sine to degree 3/2x plus c, and that is going to be our answer. 2/3 looks like it's standing in denominator, sine to power 3/2x plus c. Okay, next one, question number 2. Integral let's do e to power x cosine e to power x dx. Okay, let's look at this integral, e to power x cosine e to power x dx. So I'm looking at cosine and e to power x. They don't have anything in common, so I can't get from cosine e to power x or vice versa. But what I can do, what is interesting is we have here e to power x, and here also we have e to power x. Look what I'm going to do here. So if we have, let's say, integral cosine x, then we have to have here derivative of x, right? Integral of dx, derivative of x. But if I have integral cosine e to power x, then I have to have, instead of x, just like here I have e to power x, I have to have e to power x. This is going to be my task, to bring it in e to power x, bring it under a derivative element. So what am I going to do? Let's see. We know that derivative of e to power x, derivative of e to power x, right? It's equal e to power x, correct? Because derivative of ex is ex. Okay, so from here, what can I do? Can I say that d to power e to power x is equal e to power x dx? Yes? All right. So I'm coming back here and see this e to power x dx. I have here e to power x and dx, and I'm going to replace it with d e to power x. Okay, so look what I'm doing here. Integral. So let me rewrite it. Cosine e to power x and then e to power x dx. This together, see, e to power x dx. So that is going to be equal integral cosine e to power x, and gonna be d e to power x. Yes? Okay, very good. From here, I'm going to do substitution now. Now I'm going to do substitution. All right? Let's see. I'm going to take, this one I'll put here, these changes I made. So you will see this following changes happen after this operation here. Okay. So from here, let me see. Yeah, I was going to do substitution, correct. So I'm going to write down here substitution. It's going to be e to power x, it's going to be equal y. And therefore, we are going to get integral cosine y dy, which is equal sine y plus c, right? Because integral of cosine is sine. Why? Because derivative of sine is cosine. And we can bring back the value of y, which is e to power x, and that is equal sine e to power x plus c, right? So the answer is going to be sine e to power x and plus c. All right. Question number 3. We have integral 1 plus sine x cubed and cosine x dx. Okay, so, well, the good thing is I see here we have sine and cosine. They are kind of connected, right, through derivative. So what I'm going to do, I am going to substitute 1 plus sine x is equal t. Okay, well, and then we take derivative. On the left side we take derivative by x, on the right side we take derivative by t. So on the right side it's going to be dt, on the left side it's going to be derivative of sine x is cosine x, and derivative of x, because we don't know what x is, it could be some expression. Okay, so from here what we have here cosine x dx, right, which I can replace with dt. So let's work with this. It's going to be integral. So 1 plus sine x is t. That means we are going to 1 plus sine x t cubed will be t cubed. And cosine x dx I'm going to replace with dt. Okay? And that is going to be equal t to power 4 divided by 4 plus c. Right? And from here, if I bring back the sine, it's going to be 1 plus sine x to power 4 divided by 4 and plus c. Okay? Next one, we are going to do integral sine square x dx. Okay, so there is nothing to compare, so see if we can pair or take derivative or what other manipulation, because here all we do have sine square x, that's it. Very dry. So in this case I'm going to break it down to make more pieces out of this sine so I can work with it. And it's gonna be, I'm applying formula sine square x is equal 1 minus cosine 2x over 2. You can practice these formulas in the playlist where it says by topic trig functions. That's where I solved a lot of trig functions, some simplifications. Okay? All right, so sine x dx, I'm going to replace it with integral 1 minus cosine 2x over 2 dx. So from here, this is equal, I'm going to break down, because I need cosine by itself, so I can take integral. So I'm going to break it down and get 1 over 2 dx minus 1 over 2 cosine 2x dx. Okay, so I have parameter 2x, here I have 1x. I need to adjust this kind of right? Because you can't take integral where cosine has 2x and derivative is 1x. So I'm going to do substitution. 2x, I'm going to substitute with t. Now let's take derivative. 2 will come out and x will stay under derivative, right? X. And t, derivative of t, it's going to be dt. So from here, dx is equal dt over 2, right? Okay, we have it. So let's move back to our problem and continue solving. Integral one half of integral dx minus 1/2. I'm going to get, if 2x is t, I'm going to get cosine t, right? And dx is going to be equal dt divided by 2. Okay, so what is going to happen here? Integral of dx is going to be x, right? Because, let me do drafting. Integral dx, that means integral x to power 0 dx, right? X to power 0 is 1. So from here, this is going to be equal x to power 0 plus 1 and divided by 1, and we get x over 1, which is x. Okay, so we are getting 1 over 2x and minus, here will be 1 over 4. These 2 I'm also taking out. And derivative cosine t dt. So now I have all in own place. Cosine t dt, it's going to be sine t, right? Because derivative of sine is cosine, which means backwards integral of cosine is sine. So here we're going to get sine t and plus c. Okay. So let me write down here this formula. Let me put this way. Derivative of sine x is cosine x. And backward integral of cosine x dx is sine x. Okay, so plugging back, instead of t, I'm going to put 2x. And this is going to be equal 1/2 of x and minus 1/4 sine 2x plus c. So, and this is going to be our answer. One half x minus 1/4 sine 2x plus c. Let me solve one more problem. Question number 5. We have integral tangent degree 6 2x dx divided by cosine squared 2x. Okay, well, we have tangent to x, we have cosine to x. At least we know that tangent is connected with cosine, right? Because tangent is sine over cosine, and cosine located in the right position in denominator. Okay, so I'm going to do substitution because I have 2x there. Okay, let me use this one color. So tangent to x, I'm going to substitute with t. Why I took entire tangent to x and not 2x? Because I have tangent degree 6. If I would have just tangent to x, then it would make sense to take only 2x substitute with t. How you choose which one to substitute? You are looking which part is in not in standard shape, standard form. So we know if tangent x is a standard form, right? If I would have tangent 2x, then most likely I would substitute 2x because 2x is not standard. But because I have tangent to power 6, it's not standard. So I'm substituting entire this tangent to x because this way I will have t to power 6. And that will be easy to integrate. And then this cosine also I would take care of it because once I take derivative of tangent, it's going to be secant. And secant is 1 over cosine. So look how I'm getting to cosine. Okay. So tangent to x is equal t. So if I take a derivative, so for tangent to x, derivative of tangent to x is going to be secant squared to x. And derivative of 2x is going to be 2. So this 2, it's coming here. And dx, right? Because we don't know what x is. And derivative of t is going to be dt. Okay. Now, secant 2x is a 1 over cosine squared to x, right? Look. I'm getting closer to what I need, right? So this is going to be, this is dx equal dt. And from here, I need this piece, right? I need, see, I have dx. Oh, I even have 2 there. So, okay, let me see. I can say dx over cosine cosine squared to x, yeah. That is equal dt over 2. Okay, so look what I got. Dx over cosine squared to x. I can replace it with dt, yes? Let me this x also. Actually, I don't like that I'm writing on original problem because I would like to keep it. So let's do this way. I'll move this down. Okay. And here I'll just write down integral tangent degree 6. Oops. It has to be numerator, so let me move up. 2x dx divided by cosine squared 2x equal. Okay, this is much better. So this is going to be substituted. Here it is, the whole this piece. It's going to be substituted with dt by 2, right? So it's going to be equal integral tangent to power 6. It's going to be t to power 6. And this dx over cosine squared to x, it's going to be dt over 2, right? Beautiful solution. 1/2 comes out because it's a constant, integral t to power 6 dt. So that is equal 1/2 t to power 7 over 7 plus c. And we bring back our t, well, replaced with tangent to x. First of all, constant, it's going to be 1 over 14 Okay, t to power 7, which is going to be, let me put instead of 1, tangent to power 7 to x and plus c. Okie dokie. Here we have method of substitution for trig function under integral. And I see you in the next video. We'll see which method I will use, because there are so many methods in integral. Okay, thank you for watching. See you in next video.